Alright, for this installment, I'm going to be going over the Unit 8 notes, the parts that we didn't finish. I'm going to be going over number 7, how long till the potato hits the ground, and we'll do number 8 in just a second. So with this projectile, we still have the formula. The height equals the rate times the time, minus 16t squared. We know that the potato still has our initial speed of 40 feet per second, so our r is going to be 40. And when the potato is on the ground, obviously we start on the ground, we shoot it, and when it hits back on the ground, the height of this thing has to be 0. So it starts at 0, it ends at 0. It wants to know what time it takes for this thing to make the entire way across the parabola. So if we know our height is 0, we know our rate is 40, we can figure out the time because it will be our only variable left. So in order to get t by itself, you can either factor this thing if you really want to know how to or whatever, but just check it out. Remember, your first step with these is trying to factor out what you can of these two things first. So if we can factor out an 8t, then this will leave me with 5 minus 2t squared. Since I have something times something equals 0, one or both of these things have to be equal to 0 for that to be true. So 8t equals 0, and 5 minus 2t squared, or sorry, 2t. Hope you got that. This should be just t, because t times t will give you t squared. So that should be 2t equals 0. So make t equals 0 here, because 8 times what is 0? Well, has to be 0, which that is our start. We know we start at 0. This one is the one that's going to actually be this time over here when we actually hit the ground again. So if I subtract 5 from both sides, minus 5, so negative 2t equals negative 5, and divide by negative 2, then we know for this thing to shoot all the way through the air, it'll be 5 over 2 seconds, which is the same thing as 3.5 seconds. Oh, how about 2.5 seconds? Really bad at math right now. Just like in class. 2.5 seconds. That makes more sense. Cool. Alright, now we're going to go ahead and look at number 8. So number 8. A painter drops his paintbrush from his 400-foot building. Use the vertical motion model, VMM, to write an equation that models this situation. Use your equation to find the height of the paintbrush after 4 seconds. So go ahead and gives us h equals negative 16t squared plus vt plus s, where h is height, v is vertical force, s is initial height. So vertical force, if he's not throwing this thing down and he's just dropping this thing, he's not actually putting any force in the downward direction. So this part right here is just going to go to 0. So we don't even need to worry about that part at all. So all we're going to be left with is this height, which we want to know what it is after 4 seconds. So 4 seconds is your time. Just put it in your equation. S is your initial height. We know we're dropping it from a 400-foot building. Plug in 4, so h equals negative 256 plus 400. So after 4 seconds, this paintbrush is still going to be 144 feet from the ground. There's part A. Now, for the second part, it wants to know when the paintbrush is still 256 feet from the ground. So if it's 256 feet from the ground, that's your height. So you can just plug in 256 for your height equals negative 16t squared plus 400. Okay, notice this one only has one variable. So we can get this one variable by itself if you subtract 400 both sides. So you're left with 144 equals negative 16t squared divided by negative 16. So you have 9 equals t squared. To get this by itself, we know that like 2 times 2 is 4, or 3 times 3 is 9. So all we would do is when you take the square root of something, one of them will basically kind of go away. So you're figuring out what times itself will give us these squares. So if we take the square root, we can have 3 equal to t. So it'll take 3 seconds for this thing to be 256 feet from the ground.